Okay. So, welcome again. Let's get on with the session. And as always, with my remote sessions from home, I'm usually joined by my cats. But because this is something like 7:30 in the morning here in Lisbon, she's asleep. She might interact with us soon. She's actually looking at me now, so she might interact with us soon. Now, this is me. I've done quite a few crazy sessions in the last few years. I do try to make them as crazy as possible. Eventually, the machines will think that I'm not a threat and they will not try to kill me because I'm just a crazy guy. But recently, in the last year or so, I've done a few sessions for Bangladesh. So we started about almost a year ago in January, and I did a very quick session about machine learning is full of stars. And this was an introduction to machine learning. And then this is a part of a series of machine learning webcasts. So I continued with machines are learning, and after that, I actually continue with Come With Me If You Want to Learn ML. So the three series are actually available on YouTube. You can actually see them. And today is going to be the conclusion of this. So to actually do an actual project with this, okay? At least I'll hope anyway. So today we're actually going to put our helmets on and prepare to do some actual work. And this is our first machine learning project, okay? So, quick things, because we are on Teams, some of you might be seeing this streaming later on. In that case, this is not applicable to you. But if you are joining on Teams, you are welcome to click on the setting that says turn on live captions and just follow along if this is okay. This is also available in your own language, not all languages, but many languages anyway. And you are welcome to use subtitles if you'd like. So all of this is created by AI. So the actual message that I'm saying and what's coming out in the subtitles might be manipulated by evil robots. Okay, and if you have any questions whatsoever, you are welcome to ask, okay, either here on Teams or also in streaming as well. So if there's any question, just interrupt me. I will answer the question as fast as possible, because I just want to make sure everyone is okay and has all the information that everyone needs. So ask questions, always good. So I've been showing this lately just to make sure that this is okay. Remember, as humans, we have a different perception of the world, but machines don't really understand this. And when you go for machine learning, this might happen. And in this case, this is perfectly correct. This is a very long cow. It's called a limousine cow, okay? And this is apparently correct because no one explained to the machines that there was a maximum limit in terms of length for the cow. And the machine is actually much more intelligent than usual, because you usually get a normal cow. But in this case, because you have something blocking the way, the machines actually learn that something blocking the way, like another cow, another human, or some other like pole, or I don't know, something, can actually block the view of the cow. So they are okay with taking the beginning and the end of the cow and assume that they join it together. They just didn't expect that the cow would be so long. And obviously for a human, we can figure this out and there's something wrong with this. But for a machine, not so much. Consider this as well. This for a cow, it's exactly the same as a small child. Okay, for a small child, they would actually have this exact reaction. Oh, there's a very long cow, and then when the cow actually moved, oh no, it's two cows or three cows or something like that. This can actually happen. Okay, another example of this is a few years ago, many years ago. My niece, which was 3 years old, something like that, I actually asked her, so why do people get divorced? And this is a question that you can ask machine learning as well. And most people would say that people get divorced because, you know, they're not happy with things, or it's a money problem, or it's, I don't know, some kind of infidelity, I don't know, something. But, you know, a small child will say, oh, they got divorced because they got married. Okay? And that is actually the correct answer 100% of the time. And think of this as a state machine. And machine learning actually does this kind of thing. Think of this as a state machine. You start by being born, and then eventually you get married. After you get married, you get divorced, and then eventually you die, right? That's okay. But after you get divorced, you can actually get the state go back to the getting married again, if you are crazy enough. And then you can get divorced again. Then you return to sanity, and then you get divorced again, or get married again. So there's a circular relation here, and the machines understand that the only way you can get to the state of being divorced is by being married. Okay, so from a machine's point of view, it doesn't really matter what the social reason is for something to happen. It just matters what the state machine tells you. Current state, divorce, previous state, married. That's the reason. Why do people get married? Because they were single. That's a thing. Or if you don't have the single box, the single states, because they were born. That would be a reasonable assumption for a machine. Okay. So a machine can actually extrapolate that people die because eventually they were born. Okay, if there's nothing much in the middle, that can also be a thing. But yes, machines do not care about social conventions. They care about the actual data. And to actually say something like people were divorced because they got married is a very reasonable assumption of what really happens without social constraints. So let's see a few examples and recap the things from before. Okay, so before we talked about things like a few algorithms. Okay, Damien just before was explaining a few things about what happens in certain scenarios, etc. Because this will be on YouTube later on, but the previous video would not be directly there. I will go through a few of these, plus the previous videos that I did also cover this, so I will go through this a bit faster. So first of all, you have things like regression, and regression just gets you a value somewhere on this line. So consider this. So you have a situation where this can be, well, the weather is not a good example in this, although technically it could be. But an example here can be what's going to happen in a situation of biology or something like that. You know, the populations reproduce, they stop reproducing, etc. This can happen, and there's a sequence of time that associates with this. So the more time it happens, the more something happens here. Okay, after n amount of time, this is kind of predictable, etc. Or something else. It can be many other things. You know. But one of the examples here, let me give you an example. So you have a situation where you enter a value. So this is the value that you know, and then there's a prediction of an output value. Okay, I'm actually going to demo a few things in a bit, okay? But the last time, I think I demoed something like the diabetes data sets, which is a linear thing as well. So based on certain information, which is not just one input value, it's actually a lot. You can actually predict how this curve will go based on those values. In that case, because of the diabetes data set, it's not one dimension, it's actually a lot of dimensions. In that case, you have a lot of different combinations, 3D, 4D, etc., in which you need to see the graph. It can be not a line, but an actual plane, or if this is 3D, but probably bigger than that in this case, okay? So in this case, let's say that you have an input value of 2, whatever the situation is. Let's say it's diabetes, and you have a value, in this case it's 2, but in reality this is going to be body mass index or something like that related to diabetes. And then you go all the way here, and according to your prediction, if you move a line vertically up, this is the answer that you get, okay? So this would be a 6 in this case. But in reality, the line is an approximation of what the reality is. There's an empty area here, so most of the values are actually down here or up there or up there. So the line is not perfect. There's errors, okay? But consider this, the line is the best approximation of this, and in this one, which keeps fiddling around, this is actually the best approximation of this. How do you do this? Well, with polynomial functions, so they keep recalculating multiple iterations until, and this is what's being shown, you start with a simple curve, and then you recurve, and then you do a lot of other things until it looks better, okay? So this is the logic that you can get in a lot of different types of algorithms for, in this case, regression. Okay, so the 3D plane would look something like this, okay? But remember, it's not just 1D, 2D, 3D, 4D. It can be as many as you want, okay? Remember that the visualization that we do looks nice, but it doesn't have to be perfect, okay? Anyway, for regression, we also have what's called bias. So if you decide on something called linear regression, and this was discussed just before a bit, kind of, linear regression is just a line. So the simple formula is A, which is this value of the bottom all the way up to here, this would be A, times bx, so b would be the inclination of this curve. Is it a good idea to use this for something that's better in the blue line, in curved line? No, but sometimes the approximation is good enough for us to just use that line, because that line reflects reality not to 100%. It's never going to be 100% with machine learning, but maybe to 80%, 90%. And for us, that's a good approximation for a certain, I don't know, certain usage, okay? Now, errors. So the real value would be something in the black dots. However, if you have a simple linear regression, the line would be this one. So if you try to predict the 300, let's assume it's this dot, it's actually very close, but 300 and a bit, the real value is actually down here. So the error is quite big. The red line would be the error. Okay, so that's a big error. So to solve this one, maybe this one is not very easy. It looks quite complicated to put in an actual line. Maybe there's other ways to do this, but this one is not very pleasant to explain, but it's great to show with errors. And I mentioned the last few times that you have the possibility of this one is underfitted. So same logic here. You draw a line like this, doesn't work. You can actually overfit, so you can do training for hours and days and weeks with all of the possible information. You do a lot of training, and then the result is this. Really bad idea. Why? Because let's say that you see my mouse at that exact location. Okay, so at that, oh, sorry, the mouse disappears because it's PowerPoint. So at this exact location, I keep having to move my mouse. At this location, I would get a really bad error from down here all the way up to up here. This would be the error. However, if you go to this side, the value would be quite perfect. This would be a much better, close to the curve value here, okay? So this would be nice. In the underfitting, it is fortunate that it also works, but if you try to put the value here, for instance, okay, so this value here, where I have the mouse at this moment, this would work okay here, but this line would work drastically wrong, okay? So it depends, okay? This value means that it's perfect for all of the input values, all of the samples that you entered and you used for training machine learning, but for new values that come along, real world values, this will fail drastically. This simply is not good originally in either case, but this one that's overfitted is too perfect for the sample values and terrible for real life. The best one is the good fit somewhere in the middle. So it doesn't have to be too perfect, it has to be reasonably perfect, okay? To actually improve this, it's a good idea to not have, let's say, typically you start with a few values and you test things. You can start with a test sample of, I don't know, 70, 80, 90%, okay? But if you want to make sure that the values are good, etc., you want to increase the number of the test value. So maybe 10% for testing might not be a good idea. You want to get maybe 20%. Sometimes you go for 30%, nothing wrong with that. If you feel that the remaining 70% are good enough for you to do the training, great. And then the remaining 30% will test this as best as possible. Okay, so yeah, give it a try. Let's see, let's hope it works. Okay, so I've had this for a long time, and sometimes the data is quite wrong because you have a datasaurus or some other drawing, whatever it is, but when you try to do the average of these points, you average to zero or to something like a very simple line, etc. So to actually have a lot of weird data, etc., with weird graphs, it doesn't mean anything. Okay, so visually it looks, oh, this is amazing, this is something, but in reality might not be that good a thing. Okay, so we're still reviewing some of the things we had from the other day. I will do a lot of demos. This is supposed to be a demo project. I'm just reviewing some things. This is also from a previous, from one of the previous sessions. I will try to do a demo with this. If everything drastically fails, I took screenshots. Okay, so I have like 20 screenshots for all of the process. So if everything fails, I can still do screenshots. I hope not, but at least I have a fail safe here. Okay, so logistic regression is when you have categories. So one, two, well, typically at least two categories, of course. So two categories, which is a two-class model, but you can actually have classification with more categories. Okay, so in this case, you have a yes or a no kind of thing, or a value of A, value of B kind of thing, but it could be something else. The demo I'm going to do is using a data set called census binary census adult classification, something like that, which actually has census information from a lot of working people, and then you have the wage of the person saying that they earn more or less than 50,000. I'm assuming dollars, but it could be anything else. And it's a yes or no kind of thing. It's an A or B kind of thing. So less than 50,000 or more than 50,000. So that is two categories, okay? But you can have three categories, four categories, five categories, whatever you want. You can have many other different types of situations, okay? So let me give you an example of three types, four types, etc. Let's say you are detecting categories of fruits. Okay, so I have fruit, I have a banana, I have an apple, I have an orange, etc. And I'm doing some, image classification, and they will detect A, B, C, D, which of the fruits I'm actually going to use. Okay, so that is multi-class, but the two-class classification can actually have a lot of different algorithms which are very, very efficient, and in that case the good values are between 0 and 100%, because 0% would correspond to class A and 100% would correspond to class B. Okay, and then you put a threshold, typically 50%, but you can vary it if it makes more sense to be more precise. But in any case, this is between 0 and 100%. For multi-class classification, you have different logic, not so much this percentage logic, because you have more options. But in any case, this percentage one is very useful, and sometimes you don't need the value of A or B, you want the percentage, because sometimes there's something in the middle. So let's say that's kind of values of the people, what they do for a living, how much do they make, etc., their education. The one I'm going to show you next, let's say that's for a bank loan. So yes or no would correspond to getting the bank loan or not, based on certain criteria. So if you get closer to 50%, maybe you want to have the computer show a message between 40% and 60%, assuming 50 was the middle limit, of course, the threshold as they call it. If that threshold, which is actually horizontal here, it should be horizontal here, if that's the threshold that you are getting, in that case the 40 to 60% would be a margin of tolerance where the computer says just ask the human. It's kind of uncertain, so we want to be sure. So that uncertainty is reasonable enough for you to ask the human, so that the human stuff will ask for more information. Okay. Anyway, another example of algorithms is k-means. K-means allows you to group things by clustering, and anything that's close to, let's call it's actually called the centroids. These are called centroids, but if you want to call it center, so in Portuguese we can use centroid, but center is usually what people say on a day-to-day basis. But yeah, you can have these centroids, and they will move the centroids gradually until they find the thing. Okay, so this is clustering. So the three main types of algorithms are these, but there's more. Okay, there's things that are used for text analytics, image analytics, etc., which are a bit more detailed, etc. But the main types are these. Now, this is clustering in 3D, because you can actually cluster in 3D, 4D, etc. Remember, you might have more input values. Okay, if you just have two input values, it's 2D like you see on the left. If you have 3, 4, 5, that will be multi-dimensional, really multi-dimensional, and you can see 3 dimensions at a time because we are human. We live in a 3-dimensional world, but machines think differently, so they think multi-dimensionally. Okay. Anyway, I will mention this very, very quickly, okay? But in any case, I will show you this in detail in the actual demo. I think that this is best. In the previous examples, in the previous videos, I actually explained this in a lot of detail, but I will try to do this during the demo because it's much more fun to do it during the demo, okay? And yeah, we'll do that. Okay. Having said this, yes, not all data science is data science. This is really a sandwich by all definitions. Okay, so for a computer, this would exactly be a sandwich. You have bread in the bottom, bread on top, ham, cheese, etc. Although you should have ham under the cheese as well. But yes, that's a rookie mistake. But apart from that, this is technically a sandwich on top of a plate. So everything is correct. So what's wrong with it? Well, actually nothing, right? From a machine's point of view. Anyway, if you go down here to aka.ms/ml cheat sheets, and you actually get the current version of this, which might change in the future. I think this is still the current one, at least it was a few weeks ago, but it can change at any time, and then you can add more things. The ones that I mentioned was regression. I quickly mentioned linear regression, but you have others. I also mentioned two-class classifications, and you have a few options of two-class classification. For instance, logistic regression is actually here, but you have a few others as well. Remember, if you use neural networks, same as down here, neural networks, etc., those are usually the best trainings that you can do for machine learning. But remember one thing, it's always going to be slower, okay? So it's going to be best, but it's going to be slower, okay? For instance, the linear regression, they actually give you some tips about how this is going to work out. So it's going to be fast training linear model. So you double the amount of data, you double the amount of time it takes to do the training of that model to actually find the relevant information, okay? And in this case, this is the same thing. If you have neural networks, it's very accurate, but it has long training times. If you use a decision forest, so a decision forest is basically a decision tree multiplied by a whole bunch of trees, okay? So you have forests, jungles, and whatever you want with trees, okay? So there's a lot of names tree related, but for instance, this one is also decision tree, accurate fast training times compared to this neural network, which is long training times. But in this case here, they suggest large memory footprints, which is a little downside of this. So if you want to try this one compared to that one, the precision might even be better, but it's going to be worse for your RAM memory, okay? Long training times would be bad for your CPU for obvious reasons, but then there is a trade-off. You have to decide what you want. Do you need the information faster, etc. Nowadays with the cloud, and remember that everything I said up until this point does not need cloud. You can do this on your computer, but in any case, from a certain point on, it is good to use the cloud. And yes, you can use Azure, of course. This is a session that focuses on things like Azure Machine Learning. However, you can use any other cloud. So I'm not trying to sell any product here. You can use any other clouds and just run things, worst case, in some virtual machines. Okay. Anyway, I mentioned that you also had clustering. Things like anomaly detection are also valid. Clustering recommenders, so very not so much similar, but close to similar behavior. Text analytics, so you analyze text and you break down text, etc. Very interesting. Image classification, but eventually you can have more specialized algorithms for certain things. Okay, so let's go into interesting things and actually talk about software. So far, this was a summary of all we talked about for machine learning before, okay, just to catch up. And you don't need a data science background to do this. Do you need to learn a lot about maths and statistics and etc.? Well, yes and no. Yes, if you want to optimize the machine learning training to the best possible, okay? But if you are a developer like me, simple developer, knows a bit of math, but not a lot, knows a bit of statistics, but not a lot, knows a bit of programming, not a lot. So you can do machine learning trainings and everything in simple ways as a developer and actually get reasonable results, maybe not perfect, but if you then explore the math, if you then explore the statistics, Damien just before is a world expert in this kind of thing, so of course have a look at his session as well later on in the video if you are seeing this later. But in any case, knowing those extras will boost the quality of your machine learning trainings and your results, of course, right? But any user can do it. And specifically talking about technologies and specifically talking about Microsoft, these are some of the available technologies. So of course, the ones that say Azure first, obviously these are in the cloud, in Azure, but SQL Server 2016, 17, 19, 2022, those do not require this. Okay, so these can be done on premises if you want. Many of these, and you see the green colors here, Python, R, Scala, and you have ML.NET, which is basically machine learning libraries using .NET languages, typically like C#. Although technically, if you want to use Visual Basic, you can, but they don't have all of the wizards for Visual Basic. But you can still take the code, use that ML library, and just use the thing, and it works okay. Anyway, besides all of these, let me just mention that you also have some managed services. So all of these you can do yourself. You can do all of the steps that we're going to do next, but you also have things like cognitive services. Have a look. I do have quite a few videos online about cognitive services, all types of cognitive services. So feel free to have a look about that, also about bots as well. And you can actually have those crazy interactions with the bot, that the bot feels intelligent, but the bot is just a bunch of ifs. In the end, what makes it intelligent is the cognitive services that understand the sentences. Okay. By the way, bots and Office 365 Power Virtual Agents, these are the same thing based on the bot framework, etc. One of them is based in Azure, the other one is based on Office 365 or Microsoft 365. One is fairly cheap, the other one is expensive, but this one on the right is very intuitive and very graphical. Anyone can create a bot. The other one requires you to be a developer, at least to know C# or any other language for that matter, but something like C# to be able to program the bots. Okay, but with virtual agents you can do it graphically. Now, having said this, some of the options here, because we're going to try to do this as practical as possible, just to remind everyone, this SQLSaturday that we have today, there's going to be a lot of other sessions, especially Synapse Analytics. So Synapse Analytics can do pretty much the same things that I'm going to show you in Azure Machine Learning. although this focuses on using Spark. So Spark is an extra layer. So with Azure Machine Learning, you're going to get a VM or multiple VMs if it is a cluster, and then inside things will run, and these will run mostly in Python, although R is also a possibility. Okay, but if you run it in Synapse Analytics, you also get a machine, but it has a layer called Spark that allows you to manage how the things work inside. And with Synapse Analytics, you can do machine learning as well. You can also do what's called now data engineering, which is ETL. Okay, basically ETL, you process the data, clean up the data, fix the data, send the data somewhere else, do your usual ETL processes every day. Okay, funny enough, the Azure Machine Learning can do the exact same thing. Okay, because as long as you are willing to do it in Python, you can do it, but you can also do it graphically as well. Okay, now one of the curious things that you have is that you also have Databricks. Databricks is an extra technology that you can use for machine learning. Okay, and also data engineering, so ETL, etc. Databricks also uses Spark, and at this time, and things change because it's a cat and mouse kind of thing. Databricks is only a subset of what Synapse Analytics is. Synapse Analytics has a lot of things. Databricks, which is actually run by a company called Databricks, and they have partnership with Azure, with AWS, Google Cloud, etc. And they actually provide those same Spark clusters. In fact, the Databricks people are the same people that created Spark. Okay, so what you actually get is that you have Databricks, which deploys those Spark clusters that run this. You can also do the exact same thing in Synapse Analytics. We've seen that in previous sessions and future sessions today as well. And you can run anything Python with machine learning inside. Okay, but the Azure Machine Learning has an advantage because it has something which is the Azure Machine Learning SDK, which allows you to deploy a lot of things automatically out of the box. What's the good thing about it? The SDK can actually be used inside of Synapse Analytics. Okay, yes, you would be using a layer of Spark on top of it, which is not needed, but just if you run the Python with the SDK, you can have all of the benefits of Azure Machine Learning, but still run it inside of Synapse. Okay, what is another one of the benefits of the SDK? Well, you can actually have things like the Azure Machine Learning will have the possibility of placing all of the results, all of the information results inside of that machine learning workspace. Okay, so you can visualize it there, you can organize things. This is something called people call it DevOps. We know what DevOps is. You also have Data Ops, which is for you to do ETL and things like that. But you also have ML Ops, machine learning operations. Okay, and things like the Azure Machine Learning SDK and also ML Flow are ways so that you can orchestrate that ML Ops. Okay, but you can use ML Flow in Azure Machine Learning, in Synapse Analytics, in Databricks. Nothing wrong with that. It's just a library in Python, but in this case, the Azure Machine Learning SDK has a lot of extras which are very good. For instance, you can deploy the web services that will do the predictions of your machine learning training. Okay, so yes, that's the expectation. Okay, so anyway, time to do a demo now that we've catched up with everything. Time to do that actual demo, and things might fail. Remember, if you have questions at any time, just ask. But for now, let's do demos. Okay, so how do we do this demo particularly? You can do this in your own computer in many cases, but the demo I'm going to do now does require graphical interface that only exists in Azure Machine Learning. Okay, but many of the other demos that are available here can actually be done without Azure on your own computer, especially if you do the code-based, Python-based one, okay? But I want to keep it simple. This is supposed to be the first machine learning project, so keeping it simple, okay? So you can get Azure, go to azure.com, get started here, or actually try Azure for free if you want to. Actually, it's this one. In fact, you get like 30 days with some credits, etc., and you can use it for free for the first 30 days. A lot of things related to AI, even after that, are free because they have a free tier, things like cognitive services. So Please try it out. It's nice. If you are a student, you can actually go, let's click on free first. I need to jump into this. If you click on students, I think it's plural. Yep. If you are a student of university, you can also get free credits for a year for free, and that's $100 at this moment. You have to stretch it for the whole year, but at least for a whole year, you have access to the account and the free things that you have for cognitive services, etc. At least those you don't pay, okay? But the Azure Machine Learning, you do have to pay for the machines running. That's something that you do have to pay. Well, you still have credits while you have them. Okay. Anyway, this is my Azure portal. So once you get that subscription for Azure, you go to the portal.azure.com, and then all you have to do is to create a new machine learning workspace. So +sign machine learning. You can actually get signups if you want to. So you've probably seen this signups. You can actually get Databricks if you want to. So Azure Databricks, but of course we want machine learning. Okay. It's wrong, but still works. Okay, the machines know what we want. Anyway, make sure that it says Microsoft as the publisher, because there's a lot of things called machine learning in the marketplace from third-party vendors. Okay, and now let's click on create, and then they ask you questions. So subscription is how you pay for things. You have to pay somehow, even if it is a free account or something like that. It still has to be built. Now, resource group. I will put something like this, and then workspace name. Just keep it simple, and then yes, I know it exists. It's mine. Yeah. Okay, so let's put it as number 2, because I'm not actually going to create it now. We would have to wait 5 minutes, and I have most of the things created, but I will show you all of the steps how to do this. Think of this as a cooking show. I bake the cake and then put it in the oven, and then 2 seconds later, pling, oh, it's done. Okay, yes, it took an hour in the oven, but it's done in 2 seconds. So yes, same logic. Anyway, you just use the defaults, nothing wrong with that. All of these would be defaults, don't need to worry. And then you say create, and that creates your new machine learning workspace. So far, you don't pay anything. Well, the storage account will cost you maybe 1 cent per month. That's irrelevant, okay? But then let's actually go to the machine learning workspaces that I have created. And the one I want is actually this one. Okay, so actually it's already here. It is actually already here, but that's okay. And then you click on Launch Studio, and again, I already have it, so same as this one, but I already have it here. So yes, jumps into this one. Remember, same as signup, same as Databricks, you always have, same as Azure Data Factory, for instance, you always have a button here that says Launch, and then you go into a separate website, in this case, ml.azure.com. You don't have to memorize this, and I usually don't go directly to this, because then they will ask you, what's my subscription, what's my workspace name, etc. Very boring. Just easy to memorize the full address or keep the full address, and then just go for it. Okay. Anyway, we talked about some of these things in the last sessions. So remember that we always need to create a compute instance. Okay, I can actually start it if I want to. I think I've shown you this in previous sessions. When you click on New, you create a compute VM if you want to, which can actually run your notebooks, etc. So very, very practical. Today we're not going to use notebooks, but I want you to know that this actually exists. Okay, so you can actually start it. This is a normal VM, Linux VM. What we're gonna need is these clusters, so you can actually create clusters here. And a cluster, when you create a cluster, I'm gonna go for this one now. The wizard is very similar, okay? So I'm gonna say dedicated or low priority. Low priority is cheaper, but it might break if there's a lot of usage in Azure. This uses things like spot instances, etc. Okay, so yeah, it can be slower. It can be the same speed, cheaper, etc. But it can fail if the cloud has many usages at this moment. Anyway, CPU or GPU, if you go for GPU, it's much more expensive, but at the same time, you might do processing much better, much faster. GPU is actually very good for things like neural networks that optimizes things, okay? Anyway, virtual machine. So you choose the virtual machine you want. There's a price here, available quota, what you have available. If you are using the free Azure, free Azure subscription that you get in azure.com/free, you have limited quota, so please make sure you don't exceed these values, okay? If you use a pay-as-you-go account, or if you have Visual Studio subscriptions, credits from there, etc., you will get a bigger quota, like 20 cores or something like that. So yes, it might be different. Anyway, you click on next, give the computes a name, so something cluster, and then minimum number of nodes should always be 0, because you wanted to turn it off when you're not using it, and maximum number of nodes. In this case, because of my quota, I have a maximum of 1, because I have 6 cores quota, and this one requires 4 cores. I can use a smaller machine if I want to and have more cores, but that's okay. By the way, I already created this, so no need to worry, okay? In fact, everything was already run, because doing a machine learning training, the simplest ones that I have here takes about an hour, and obviously we don't have that amount of time. Okay, inference clusters. So you can send things out to things like Kubernetes if you want to, but you can also send things out. Okay, so just to explain this. So what do you use these for? So first of all, so the compute instances will run your notebooks, and your notebooks orchestrate what you want to do. Okay, and then you either run the actual machine learning training in that notebook directly, in that VM directly, which you can do. It's the same as running on your computer, but in many cases use those clusters, because those clusters can have many nodes and run the machine learning training in parallel. Okay, so obviously much better, but that needs to be orchestrated by a VM, which instead of using this one, you can use your own computer to save money. Exactly the same thing. All you have to do is to have the Azure Machine Learning SDK installed in Python, of course, right? Anyway, once you run the training, training is done, you generate a model, which is your magic values that the machine actually learned. So it's the small amount of values that you learn. You can start with a petabyte of data and end up with just a few kilobytes of magical information. And then you can use inference clusters, inference, compute to actually predict the things, and that's extremely fast. So that can be one single container. You can use things like Azure Container Instances for this. You can use Kubernetes that I mentioned. You can use Kubernetes if you want to scale it a bit bigger, but you can also use a virtual machine. Okay, so currently there are options for you to deploy to a virtual machine. Okay, now you can also use other computes, and in this case you can actually use computes from Databricks, so Spark from Databricks, Spark from Synapse, a normal virtual machine, Kubernetes containers inside and run things there. HD Inside is a bit old, but you have Spark there as well. Data Lake Analytics is considered obsolete, and so on. So you can actually do things, and the virtual machine that you have here can be defined by yourself. You can customize the machine by yourself, so you can actually run through that machine if you want to optimize it for some reason. Okay, now compute is easy, but I think one of the last times I've showed you the AutoML, and at the time I think I've shown you the diabetes experiments. Okay, so the diabetes experiment is you start a new Azure ML job, and you select a data set. So you can actually create a data set from, let me just write something. You can create a data set from open data sets, and this open data sets has a lot of different data sets, like the diabetes sample and a few others that are available here. Okay, so you can actually use this if you want to create a data sets. So actually you could create it here directly, but the wizard does this for us, and then you select the data set, and then you say, oh, I want to run a regression or something like that. So you do all of the bureaucracy names, etc. You are targeting the Y column, which is the results column. Okay, so all of this is inputs, which is your age, gender, body mass index, how fat you are, pretty much, blood pressure, a few other settings, and then the Y is going to be a value that tells you if you have diabetes or not. Okay, or likelihood anyway, in this case, might not be the exact number, okay, but this is what's being predicted. So if you want to predict the Y, the result, this is what you need to do. So you can run it in a cluster, or you can run it in the instance, so the individual VM if you want to. So either is okay, you click on next, you say I want regression, which makes sense, and then you run the whole thing. You can even have others, classification, but also others, and then a few other settings here. Click on next, a few final settings, and once you click finish, that will actually run a training, okay? And that training, just to get you an idea very, very quickly, if you go for this, because it's AutoML, they will actually try to do a lot of different combinations of algorithms and parameters, hyperparameters, etc. They will do a lot of combinations. One of them will be the best one, okay? I'm not sure which one is the best. I would have to check, but one of these, probably this one, silly match, but I can't remember which one it was. In fact, I would have to look into details, but one of these would be the best, and then you can use that to deploy things and to actually do predictions, okay? So the last time we saw something similar to this, okay? And you also have notebooks, okay? So these notebooks, you can actually go for samples. These are actually from version 1, but version 2 has been released recently. You can use it as well, but the ones I have here are for version 1. So you have tutorials, image classification. So you can actually have this one. You can go here. Let me just go here. You can click on this one and say clone. Once you clone it into your own file system. So users, Andy, that would be me, okay? By the way, all of this file system is in a storage account, okay? In a file share in a storage account. So you don't need the workspace. You can access it directly. You can even mount it on your computer if you want to, okay? Now, this image classification, for instance, let me just show you the results of the first one. So once you actually run it, so this was run already, okay? So you can deploy a cluster just by saying this. Oh, let me just shrink this for a bit, if that's okay. Oh, I'm here on notebooks, but yeah, I'll be here, no worries. Okay, so if you go here, you actually say, oh, look, I need to run a cluster. If the cluster already exists with that name, fine. If it doesn't exist, create a new cluster with this configuration. Minimum nodes, maximum nodes, VM size, which is pretty much this definition standard whatever, okay? And then just say compute target create. How easy is that, right? And then wait for completion so that the script does not continue because this is asynchronous. And then this will actually continue and get the data. This is an open data set, so you get the data. Microsoft has this library here that can actually have a copy of the data sets ready for you. They are actually somewhere in the cloud, but they make it easier for you. Otherwise, you have to get the data yourself, which you can still upload, which is perfectly okay. Anyway, you can analyze the data by using Python, etc. All of this that you see here, you can do on your own computer. You don't need to be here, okay? And then eventually you're gonna do the training. All of this is the training. Okay, and this is done by code. I'm not going to go into a lot of details because I really want to show you the graphical interface. To keep it simple, this would be advanced level, okay? But I still want to show you that this exists. But now let's go for the designer. This is the fun stuff, okay? So the designer, this was actually created in October at some point in time, okay? And you can actually have some samples that already exists. A lot of samples are available. This one, I actually created this from scratch at the time, okay? But give all of these, show more samples, all of these, you can give them all a try, and these are fun, okay? But for now, I'll actually just use this one. So I will start with this. So all of this has already been done, to be honest, okay? So in fact, I'm not actually going to reinvent the wheel. This has already been done, okay? So I created this already, and then I clicked. So I've dragged and dropped all of the boxes. So sample data, adult census, etc. So it's actually just the first one. What is this? You right click and say preview data, okay? So this data, let me just increase the size of this, has 32,000 records of people's age, work class, etc., education, and then education, marital status, race, sex, etc. In Europe, this would not even be allowed, relationship, etc., and then country, and then hours per week. So most of them will be 40 hours. The big number here is 40 hours, which is the average. It can go all the way up to 80 and sometimes maybe 13, which will be the smallest ones, okay? Capital gain and capital loss, it's mostly zeros everywhere, but there's a one or two values that actually has a number. This number, if it exists, will boost, well, not the loss, but the gain, will boost this to bigger than 50,000, you know, euros, dollars, whatever income. Okay, so any value here other than 0 will probably raise this to the top because that's what the machine learning learned. But most of them are 0, in fact. Okay, if it is native country different than the United States is the vast majority. If it is different, the income, which is skewed and really badly assumed by the machine learning, they assume that the income is less. But somewhere down here, I'm not sure where, but they will predict that someone that lives in Ireland, there's a value there that says Ireland, a guy that lives in Ireland will probably be making, is making more than 50,000, but they assume that they're going to make less because they assume that everyone that is not in the United States has a bad income. That's what the machine thinks, okay, because of what they learned. Because most of the values are Cuba, Jamaica, and so on, but other Mexico, etc. But when you go to Ireland, which has a very reasonable wage, that suddenly changes. Okay, so yes, they can have issues, but let's assume. Okay, so let's get rid of this one, and then all of the rest is simple. So adult census. So what can you do next? You can actually go here. Let's go for components, and you can actually do data transformation. Now, I'm not going to do it in the middle. The data is already done, but you can say, oh, let's add a column with something, add rows if you really want to, add some math operation like multiply something with something, etc. But you can also apply SQL transformations. You receive things as a table, and then you apply SQL like select field 1, 2, 3, where something, group by something. So instead of doing the transformation in Python or in one of the other boxes, you can do a SQL transformation here. Most people know SQL, so it's easy enough to run it as if it was SQL. Clean missing data. So if you have empty values, you can actually clean them up, and that will be okay, because machines don't like empty cells, empty fields with empty values. Okay, clip values. So to limit this outlier, some minimum values, maximum values, you cut them. Convert to CSV, data set, etc. So conversions, group data into bins, groups of ages, 0 to 10, 10 to 20, etc. or some other value. Okay, join data, normalize data, normalizing data. So when you have data that has different possible values, you want to normalize it. Plus, if the data is between, let's say, 0 and 200, let's say, you want to probably convert the data to 0 to 1, so that the data is always decimal from 0 to 1, because machines like data between 0 and 1. Okay, mathematically it's better to actually process it. Okay, so we need to hurry up and actually do this, so let's go for this. We're running out of time. Anyway, once you get this, so you divide the data into the testing part and into the training parts. So testing, if you double click, it's going to be around 30% for testing and 70% here for training. Randomizing is always a good idea, so that the training will be different every time, and if you get consistent results, this is good. If you don't get consistent results, you might have a problem. But in any case, I chose an algorithm. I decided to run a training box, so you drag and drop from left to right here, and then the result of the training box is a model. So that's the magic values that come out. Score model, to do scoring is actually to do predictions. So I'm going to score that model, and then eventually I'm going to evaluate it and see what the actual result is. Now, the next step would be to click the submit button up here. Okay, and that would run the machine learning training again. That would take an hour. I have the result here already. Okay, so pipeline jobs, I have the result here already, and that will actually turn everything green. Okay, and then you can actually go and see preview data, evaluation results. You can actually see the evaluation results of this. So the curve is okay because they predicted yes or no. A good curve would be closer to that number 1 there, so very square, but this is not perfect. Okay, so the good values are here. This is a confusion matrix. So the good values are in the diagonal, so always in the diagonal. That predicts the value, and the actual value is the same. So correct, correct, incorrect, incorrect. If you move these around here, you actually get values either very incorrect on one side or very incorrect in the other, okay? But somewhere in the middle, this would be the correct one, so the diagonals are as most correct as possible, and this one are as least as possible, of course, right? And you can have more details. Scoring models, you can compare preview data, scored data set, you can compare the data, the original data with the trained data. So up here, real value is this one, scored labels this one, and then the probability from 0 to 100%. Most of these are correct, and one or two will fail. Not sure where, but there's going to be a failing. This one will fail. This one says United States. It says less. This one is scored labels more. You get 62%. The threshold is 50. But in reality, the income here is actually less for some reason, okay? And you can see the details, but I'm going to skip that part. There is more, of course. There are more errors, but you can skip that part. There is, for instance, Poland also got it wrong, so income was good, but the scored labels were bad because they said 24, maybe because they said Poland here. There's also another ones for, oh, this one as well, England as well. There's also Ireland, so there's a lot of countries where this gets it wrong because they assume anything outside the United States is wrong, okay? So very good to know. Anyway, you do this, and then you click on this button that says Create Inferencing Pipeline. So you can do things like a web service so that you can predict it, okay? And the inferencing pipeline would look something like, oh, give me a second, designer, pipeline job. So the result of that would look something like this. So you would need to click on submit as well when you get the result of this, and this is the result of submitting this. You have web service input, which is you receive the data to do prediction, and then you predict things in scoring, and then you get the result out, okay? This is the trained model that you have been using, makes sense, okay? This is what was generated from the training. This is just to give you the sample of the schema, the input schema, what fields you want to ask, etc. It goes into the same box. Feels weird, but this is how it is actually done. Okay, but in any case, the result will be okay. You just need this one, you just need this one, and you get results. Once you do this, you click on deploy. Okay, now I've done that already. By the way, just to remind everyone that you can have that model here. So I have my census model. Okay, and I can click on deploy here as well, but it's good to click on the other one because it's more complete. Okay, but you can actually have the model here. You can download the model if you want to, so the actual file, so that you can use it on your cell phone, on an IoT device, something like that, on your application if you want to. But yes, you can click deploy here or there in the designer, and once that is done, you generate an endpoint. And my endpoint is, this one specifically is an Azure container instance. So it's basically a container floating around in the clouds, okay? Now, this takes a bit of time, like 5 minutes, okay? Just to give you an idea, this is actually here, okay? So this is container instances. This is the actual value, okay? And this value here is running, so it is started. It's Linux. There's an IP address for this, fully qualified name. That's the one you want to use. And it's actually running. I did some testing, so it is actually running, okay? And if you go for this one, it's actually going to be here, details healthy, that's what I want to hear, and then testing, so I can test this, okay? So they give you a lot of examples, and I can actually click on test and get all of the examples based on this. So based on the inputs, I get the results of the output. Let's focus on the first one, okay? So income probability, scored labels less, probability very, very low. Remember when I said that you can have capital gain, and that would make a difference. So let's add a big value and see if this result will turn bigger. And suddenly 98% changes completely. So yes, I am hacking the thing, but yes, this is a good example on how you can do this, okay? Obviously, you replace this with your own data. This is supposed to be a REST API request, so using HTTPS, but this is your first machine learning project. How do you do it? Well, before that, let me go to deployment logs and show you that I've actually tested this with a lot of zeros. So somewhere a lot of zeros. So capital gain, a lot of zeros. Okay, so that's the one. Okay, and then you get the results out. So they give you scored probabilities. This, what I want is somewhere 98, probably this one. Okay, so capital gain, and then the probability is this. This is the result of running that test. Okay, now Testing is fine. You can test this as much as you want here before you actually do your own application. Elaborate capital gain. What does this parameter actually do? Well, it's just a parameter that says you won money in the stock market or something like that. Okay, so that is actually, this is a lot of inputs that you get for the user, okay, and then they will try to predict this last value. So in this case, capital gain and capital loss is how much money you make in the stock market, how much did you lose, and so on. Okay, all the rest are a bit more obvious, except this one. No idea what it is. Education and education numbers, these match. Okay, so the bigger number it is, the more education you have. So it's kind of sequential, but these are one of the same. So you can just have one of the fields. One of the things you can do is, oh, let's delete a row because one of these are redundant. Okay, so that's would be a first step that you do ETL before you actually split the data to run the training. Okay, anyway, let's consume it. This is why we're here. Let's consume it. REST API, so that address should be the same as this address. C4 something, that's okay. And then authentication, I have some keys, okay? And I can use these keys to do the prediction. Where can I do the prediction? Code in C#, in Python, in R. Well, I'm actually going to do it in C#, okay? So I'm actually going to copy this, and I'm going to start my Visual Studio. So File, New, Projects. I'm going to keep it simple. You can use a website, you can use whatever you want. You can put this in a library, which is the best recommended way, but because I want to keep it simple, console application. In this case, it's C#. So this is console app 2. So I'm going to put it here, console app 2, and I'm going to click on next. .NET 6, this is okay. They require a minimum, so the text somewhere will say they require a minimum of 4.7. This worked. I tried this like an hour ago, so this worked. Okay, create, and hopefully this will be okay. So first of all, you have program.cs. It's empty, of course. And here I'm actually going to copy paste this, make sure it's copy pasted. Funny thing. So you require Newtonsoft JSON because you want to process the JSON. So you can go here to Tools, NuGet Package Manager Console. This is the one I have here, and you have to add install package Newtonsoft JSON. If you want to parse the JSON, of course, you might not want to. Okay. Nowadays there's better options, but you can do it. You might also need this one. So you might also need this one because they say you're going to need this one so that you can do the actual requests. Okay, so just in case, sometimes it's automatic, but just in case, I'm going to install it as well. Okay, so this requires a lot. Okay, and by now this should be done. So I have this. So what do I do? Submine, you just request the thing, and inside of this you're actually hard coding the values here. Okay, however, oh yeah, this is okay. You are actually hard coding the values, but if you want to do it right, you replace these values with variables, and you put the variables as an input somewhere here. Okay, so you can have this as a task, or you can have this as a part of a library. Okay, and then you have a function that says, oh, here's all of the questions, so you can input maybe a class with all of these properties, or simply have these as parameters, whatever you want. So you put all the values here, and I have capital gain 2470. I'm going to put 9s now, just to be different. Okay, 9s are okay. Be careful not to exceed the 5 digits. Sorry, the 9 digits, because it might be a 32-bit integer. We don't know. Okay, the rest I'm going to keep. I'm not going to care about the other ones. And then what they're going to do is they're going to use my API key. And they're going to say headers, authentication headers. That's going to be my API key, because you need to authenticate your users to be able to use it. So you can do this for free if you want to. You can change the thing and have anyone use it, but this is always recommended. And then you call that thing. This is already done for you. You don't have to do anything. It just copy pastes, okay? And then say you have an application JSON, and then you ask for the response. Post the sync, and then if this is correct, print it on the screen. If this is wrong, here's the error. I'm just going to add something here, which is console.write, write line ends, and then console.reads line, just so that we can have some timing. Okay, so I'm going to run this. This is my last demo. Okay, I'm running a bit off time. Oh yeah, this continue. Yeah, sure. This is a different bug, unrelated to our problem, just related to my installation of the thing. And I need to process this. So how do I do this? Let me go here for something like this. It can be anything you want, okay? So I've have this here already, but I don't want to cheat, okay? I don't want to cheat this. So I'm going to copy paste this and copy this here. Parse results. Yes, because I have results here. Yes. Validate. Revalidate it. Okay. So results is this. So all nines, this is the test that we did just now. Okay. And obviously probability is 9999. Okay. So that's fine. This actually continues from here. It just doesn't fit. Okay. It's actually part of that one. And the scored labels is this. So now you have this result shows up as JSON. You need to parse it, of course, on your application, but it's ready for you to use and show to the user, yes, you are able to receive the bank loan based on the information that you provided here. So a yes or a no. So yes, you make enough money, we'll give you the bank loan. Okay, so yes, good enough. Okay, so the rest is up to your application, of course, right? Anyway, this is all. I'm running out of time. I've exceeded my time, in fact. So let's just move on. Okay. And I'm not sure if anyone has any last questions. But in any case, I want to thank you all for being here and watching this session. This is actually part of a 4-video series. This is the last video, of course. So thank you all very much for being here. And yes, hope to see you next time. Okay, so let's stand by for the next speaker. Thank you all.
Thank you. So